I'm emeritus. I used to have Andre's job, but I'm here to give a little short prelude. In autumn of 1978, I was a brand new assistant professor put on the graduate admissions committee, which was fantastic. And I had just been a graduate student, so I had no terms of reference to read these and judge good or not so good. So they gave me a stack and I started reading and quickly gained a sense of quality on some scale I was creating. And about halfway through, I read an application that just startled me, it stunned me. And I read it a second time from this man in Mexico, or applying from Mexico, who I realized had a career already that surpassed mine in any way it could be measured. He was almost done with a PhD from Argentina. He had dozens of publications, a world expert on polychaete worms, known far and wide. But he had fled Argentina in the military regime with his family, and from Mexico applied to the School of Fisheries. And I took the application to the chair of the committee, and I said, I don't know much, but I think this is really good. And it was passed around. Enthusiasm was immediate, and we had the great good fortune of accepting, there we go.
Sorry, predicted.
We need to go back. Josemaria Lobo Orensons. And he came to the school and changed so many of our lives in the most positive ways imaginable. Lobo, now this is going to scroll through just a cavalcade of his life, but he was a man of many dimensions and talents, one of the best ecologists most of us have ever known. But he was a fun person. He was a generous person, a kind person. And he took his science beyond just science for fun and its own sake. He made it relevant day after day in the world. He was a passionate conservationist, and both he and his partner, wife Ana Parma, also an alumnus of our school, were appointed Pew Fellows. They've worked together on dozens of projects around the world. And Lobo was very instrumental in working, especially in South America, to change the very bureaucratic top-down structure of management to co-management, an advocate of, that's his parrot, by the way. On one, an interesting dissection technique. He taught crustacean biology here in the school. He was always reading, but then he was always partying. And those of us who visited Lobo and Ana in Puerto Madryn, down in Patagonia, always came away feeling we were part of the most exciting, generous. There's Ray Hilborn being trained as a gaucho. Lobo was passionate about Argentinian skewered lamb. So here's Juan Valero, who put this together, getting ready at Ray Hilborn's house. Wine, the mix of conversation, it was all so much fun and stimulating. Lobo was generous to all, funny to all. He was committed to students, to undergraduates, to graduate students. He was on so many committees in this school. So many people now in various NOAA careers benefited from Lobo, the very kind but critical mentor, here on a boat in the wilds of Chile, sampling sea urchins with Ana, riding back after a horrific storm. He agreed to wear one of my Hawaiian shirts. Kirsten Holmesman, one of the many students who benefited from Lobo's time in their life and involvement. This was a really special person. And he rode into the sunset recently, and we're going to miss him a lot. Monday, Lobo died. He was loading a van in Puerto Madryn with Ana to go on a field trip. They were going to head south to the penguin colonies, maybe see D. Boersma, and he fell to the ground and he died. So if you could pick your circumstances, the moment before death, he was very happy. And there was a meeting on Tuesday with Daniel Webb back there at the Dean's Office, Advancement, and we immediately made the decision with André and Tim Essington to start an endowment. And in my 14 years as director, I have never seen an endowment come to life so fast in record time as this that's now alive and active in memory of Lobo Aransas. It's an endowment established for student support. Andre and I are going to send you a very short one-page letter far and wide today or tomorrow that has a link in it. And Jan and Juan and I got to test it this afternoon. And it's like getting the first print of a limited edition to go in and donate your money. And it really works. It really works well. We are absolutely confident, totally committed to breaking through the $25,000 minimum threshold to make this endowment operational. Friends are writing us and, of course, Anna from all over the world. So we're quite confident this endowment will come to pass very, very soon. Please feel free to send this out beyond the email you receive. Who knows what contacts we might miss. So we thank you, Lobo, for the time you gave us in your life. It's made us all happier and better. Lobo would be so thrilled to know that following this very brief tribute, today's entertainment is going to be provided by André Punt. But Andre, good luck. He's a hard act to follow. And here to introduce Andre, who needs no introduction, is Julia Parish. Okay, you're going to hug me.
I will hug you. Okay, hold on. Why does this always work for men and never for women? So I'm Julia Parish. I am actually a professor here in fisheries, but I make my living these days being the evil queen associate dean over in the oceanography building. And it's my great, great pleasure to say, wow, Bevan 15, who knew? This is fabulous. It is one of the most well-known, famous fisheries symposia, and getting to be kind of one of the oldest, not only in the country, but in the world. And so that's a great tribute. And it was started by Tanya Bevan in memory of her husband, who was a dean of the then College of Fisheries. It is sustained by an endowment that was started by Tanya and the Bevan family. And also we have very, very significant contributions from the Northwest Fisheries Science Center directed by John Stein, and the Alaska Fisheries Science Center directed by Doug DeMaster. So thank you to all of those people. So Andre, you know, you can't introduce Andre without being numeric. So I gathered some numbers, which I would like to share with you, and we can have a little bit of a guessing game about what these numbers are. I don't know whether you've listened to that part of The Economist on NPR where they trade numbers back and forth. So I'll throw out the first one for you, 8.75 million. No hesitations? Yes, it's the number of annual airline miles that Andre racks up. No, actually, it's his total grant and contract funding that he's brought into fisheries since he's been here. Go team. Yes. Okay, and how about 217? Number of emails sent before 6 a.m. daily. It's actually the number of papers in the new millennia that Andre has published. Yeah, remember, you young ones, there was a millennia before this one. We were alive in it. 71. He hides it so well, does he not? It's the number of graduate students Andre has advised either as chair or as a committee member. Yeah. How about 30? It was actually his Pepsi Max daily consumption before Michelle cut him off. No, it's the number of days annually that André says he spends working on the scientific committee of the International Whaling Commission, along with many, many, many other commissions and task groups and planning groups and working groups. André is the most commissioned, planned, task force groupie guy that we know. 3. Right, number of hours André has slept this year. No, it's the number of times that André won the COFS, which is the College of Ocean and Fisheries Sciences, Distinguished Research Award. He actually won it 3 times, which says a lot about André. And 4.3. It's the average number of authors on the papers that André has published, and it tells you a lot about him. That is, for André, working in science is teamwork, and he has many, many, many members of his team. And so today, André is going to tell us, I love this title, is it easier, I wanted it to read, is it easier to manage all the faculty in the School of Fisheries than fisheries itself? But no, it is instead, is it easier to manage marine mammals than fisheries? Tales of successes. André Punt.
Julia?
Yes.
So if this thing stops working, what does that tell me?
You're out of time.
I'm female. Okay, well, thank you for that. Shocking. That was just the most amazing introduction. I almost feel I should stop now and leave. I actually didn't know most of those statistics myself, and just to, while I try, why can't I used to be able to use a touchpad, but apparently I can't do that anymore. We're gonna miss Lobo. Lobo was on Cody Suzwalski's committee. Most of you, well, many of you remember Cody. He graduated 2 or so years ago, Lobo is just a wonderful mentor, and so for those of you who knew Lobo, it's sort of losing a member of your family. I think all of us were horribly shocked. So I got to give a talk. Right. So, okay. So in fact, I've lost 90% of my time. That was another number you did not give, Julia. What we are doing this year for the Bevan series is having topics which are controversial, and for each topic we're going to have 2 speakers, and so I'm the first at bat on aspects related to whaling, but I decided to take a slightly different tack than Mark Mangal, who's going to be talking next week. I'm really linking whale management and fisheries. So because we need some numbers, and we didn't need, I thought it would start out by seeing how much biology you know compared to me, right? So here is a species. What is it? Lives to 100 years, matures at age 8, depleted by harvest over a short period of time. We've basically stopped harvesting it, and it's slowly rebuilding, but not very fast. What is it? Come on, what species? A whale? Which one? Owen, you should be paying more attention, my friend. It isn't a whale. It's Pacific Ocean perch. Owen does the stock assessment, so he's actually responsible for it not increasing. He's responsible for the catch people. That's true. The reason I wanted to identify POP at this point is just to start to make the analogy between the dynamics of whales and the dynamics of some of the fish species that we are required to manage. POP has pretty much all the same challenges that you would have as if you were trying to manage a blue whale. Apparently, though, for those who are more biologically inclined, recruitment variability is a little lower in whales than it is in Pacific Ocean perch. Although I'm told the egg production from most whales is fairly high. So, as a mathematician, I needed an equation. I was told I wasn't allowed a lot of equations. So here's my first equation. So I tend to think of fisheries as a mathematical discipline. I'm not necessarily, people don't always agree with me on that, but we need an axiom if we're going to do mathematics. And an axiom in fisheries management is given by this quote from John Shepherd in at least the last millennium, probably in the early 1970s. Most of you have seen this. Counting fish is like counting trees, except the trees don't move and you can't see them. And we say this because when we as fisheries managers don't succeed, we can always look at the foresters and say, hey guys, think of how much more difficult it is to manage fish. So mathematically that can be written, fish is not equal to trees. What I'm going to evaluate today is I'm going to talk about possibly marine mammals are approximately equal to trees. And we'll see how true that might be. So I'm going to touch on a number of topics today. I'm going to start by just introducing folks to whaling and what makes whaling slightly different from fisheries. Talk a bit about the International Whaling Commission. Then I'm going to do a quick review of status of stocks of both whales and fisheries, and talk about a few challenges to both fisheries management and management of baleen whales. And then I'm going to draw the normal conclusions. So let's start with some critters. These are the whales that we're talking about. We're talking about baleen whales. I'm not going to touch on toothed whales except in a very, very limited extent. I've divided, or more correctly, biologically, the whales have been divided into 4 groups. The ones that, the main groups are the right whales, which include, surprisingly, the right whales. I learnt this while I was preparing the talk. And bowhead whales. And the other group are the rorquals, which include most of the great whales. I'm not going to talk about pygmy rights and about Eden's whale. To some extent, Eden's whale is still under discussion whether it actually is a separate species. But there's no data for it, so I won't focus on it. But I will note that these are very big animals. So here is a comparison between the space shuttle and a blue whale. The space shuttle is longer, but in terms of longevity, the blue whale, millennia, space shuttle, really not so much. So we've got species, but just like fisheries, we've got stocks. This is for bowheads. There are 5 identified stocks of bowheads. If you're a salmon biologist, close your eyes and ears now because our stocks are a little bigger than yours. In the case of bowheads, we've got a stock here in the Greenland Sea, one in the Davis Strait, Hudson Bay, the Okhotsk Sea, and this big one, this big area here north of Alaska, the Bering Sea, the Chukchi, and the Beaufort. And I'll be talking about that stock several times. But so for every species, we divide those species into population units, and we manage them. Okay, well, we don't really manage anything. We don't manage any animals, we manage people. And the people who do the managing in the case of whaling is the International Whaling Commission. It was established in 1946, so basically straight after the Second World War. And the interesting thing about the Whaling Commission is it's a model of how institutions change over time. So when it was established, the preamble to the convention which established this back in 46 says we're developing this International Whaling Commission to provide for the orderly conservation of the whale stocks, the proper conservation of whale stocks, thus making possible the orderly development of the whaling industry. So the International Whaling Commission, when it was set up, was a way essentially to allocate whales between nations. And a couple of times people have said to me, I'd really like to go to the Whaling Commission. I want to see what it's about, right? And so the response is, you can go if you're a country. I'm afraid most of us are not countries, although you can buy them for a small amount of money. The Whaling Commission itself consists of a number of nations. There are ones in blue here. They're the ones we tend to think about when we talk about whaling today. Whoops, that went the wrong way. We've got Japan, we've got Norway, and Iceland are the main whaling countries that do commercial whaling or would like to do commercial whaling. But there are a lot of other countries that are marked in blue here. You've got countries that are involved in what's called aboriginal whaling, Denmark or Greenland part of Denmark, Russia, there's whaling here in the Caribbean, and of course the country that does, in many respects, the highest amount of whaling expressed as a fishing mortality rate, which is, of course, the US of A, right? The US is a whaling country and has been for millennia. So whaling takes place in Alaska for aboriginal purposes, and some of you may remember that I think it was 1999, there was an attempt to harvest a grey whale off the coast here. So the US is part of the commission. There are a number of countries that were whaling countries. Australia, well-known whaling country today. South Africa, Peru, the United Kingdom, the Netherlands, Spain. These are all countries that used to be whaling countries and were members of the Whaling Commission back in the day in order to get the most they could get. And then you've got all these odds and sods countries which have joined ever since. And there are some interesting countries in here. One usually doesn't think of Mongolia as a whaling country. Switzerland is a long-time member. Its catch history would suggest that if we ever start commercial whaling again, it's not going to get a lot of catch given its previous catches. And so different countries come with very different perspectives on whaling. So why did the Commission start? Well, the Commission started because of essentially unregulated whaling in the Antarctic. So starting in the early 19th century, that's the century before this one, right at the beginning of it, so even possibly 1 century ago before that, whaling started in the southern hemisphere primarily from land stations. Here's an example of a rather decrepit looking land station. I think this is South Georgia. The whaling industry, these are catches in number, increased very rapidly, mainly because of improved technology. You could get to the whales, you could catch them. The consequence of that was increasing harvests of particularly blue whales, which are in blue, and fin whales, until what we fisheries people call the Great Fisheries Conservation Closure. Most other people call it World War II. You can see the catches going down, and the Commission was started here. What's evident in this catch series, if you look at it carefully, is that blue declines to 0. Then fin whales decline to 0. Sei whales decline to 0. Sperm. Oh, you can't see a cursor. Okay, that is interesting. Okay, so technologically I am once again challenged. Okay, well, I will point at the board with a big stick, which I do not have. Okay. Okay, I will point at the board as if I had a stick. The most important point here is that you can see these lines going to 0 essentially as each of these fisheries is closed by the Commission. The last line here, the sort of bluey type turquoisey thing, is minke whales. They dropped to 0 in 1987 or close to 0, but that's not because they ran out of whales. So, what do we mean by whaling? People think of Japan and the US as whaling countries. There are 3 types of whaling. I'm going to talk about 2, and Mangal is going to talk about the 3rd in lots of details. That's what happens if you spend 3 weeks in a court case. So commercial whaling is whaling for commercial purposes. At the present time, it is under a moratorium. There is no legal commercial whaling except by Norway, which provides what's called an objection when the moratorium was adopted. So the Whaling Commission has this interesting concept that says if you don't like a regulation, you can say, I don't want that to apply to me. And the Norwegians, in one sense, were smart enough to realize that that might be a good idea if you're going to have a moratorium. Aboriginal whaling is whaling here to satisfy cultural and nutritional requirements. And then the final type of whaling, and I've quoted from Article 7 of the Convention here, is what's called special permit whaling. That is the correct term for what we colloquially call scientific whaling. And that will be the focus of Mark's talk. I won't read all the text, but I will focus on a few words. And those words are that a contracting government, someone who belongs to the Whaling Commission, may grant to any of its nationals a special purpose authorizing it to kill with subject to such restrictions to numbers and other conditions. This is a very broad convention clause, and it's been used by many nations over the years, including the United States. Of course, in recent years, this is been a much bigger component of the catch than it was in the earlier days. So 3 types of whaling. I'm only going to focus on 2, commercial whaling and aboriginal subsistence whaling. Commercial whaling is pretty much, has the objectives that are pretty much the same as those of any fishery. You want to catch as much as possible, you want to do it sustainably, and you want the catches to be stable. And particularly from the point of view of the fishing industry or the whaling industry, stable was important. What I do want to emphasize, if I had a pointer or a large stick, is the second dot point here. This is one of the objectives of the Commission. These were set up in the 70s and 80s. Catches shall be 0 for stocks below 54% of carrying capacity. Okay, who is a fishery manager? Who does stock assessments? I'm looking at you, Owen. Put up your hand at least. Come on, some of you do stock assessments. How many fish stocks are closed when they are below 54% of carrying capacity? As many as I have had Coke rather than Pepsi today. 0, right? Even back in the 1970s, this was a very conservative objective. Aboriginal whaling is in many respects an operation that has a lower tolerance in terms of conservation. You'll notice reference here to risks of extinction rather than carrying capacity. And unlike Aboriginal commercial whaling, the aim is to satisfy the needs of Aboriginal peoples, not to maximize catch. There is a moratorium on commercial whaling. I'm sure you can't read the right-hand side of the slide that well, but hopefully you can see all these zeros. Okay, there's a document that lists every whale stock in the world with a 0 next to it. You suspect that's a little on the pointless side, but there you go. This is actually the schedule of the Whaling Commission. The moratorium was implemented it was voted on in 1982, implemented in 85, 86, and as part of the agreement, this piece of text was written. And by 1990, at the latest, the Commission shall undertake a comprehensive assessment of the effects of this decision, the moratorium, on whale stocks and consider modification of this provision and the establishment of catch limits. So, Julia said that 19-something was last century. Well, she must have been wrong because the Commission have actually never done this. And when you hear Mark Mangal next week, part of the, dare I say, motivation for using scientific whaling provisions is that people have some people anyway, have a sense that they have been given a bad rap because at least the people who agreed to the moratorium assumed that by 1990 there would be some re-evaluation of that. What are the consequences? Many of you have seen figures like this before. These are catches by Japan from 1985 to the present, or close to the present. This is the period of commercial whaling. You might notice the bars are somewhat larger than later on. At that time, Japan was taking minke whales in the southern hemisphere. These brown bars. They were taking whales off Japan, Brutus whales and some sperm whales. This is the moratorium coming into place. What you're seeing here is the increase over time in catches under scientific permit. These catches are both in the Antarctic and in the North Pacific, and the number of species you might notice has increased over time as well. As I say, I won't spend too much time on this, but just to give the context of what's driving some of the things you'll hear from Mark next week. So, status of stocks. How are we doing in terms of stock status of fish and whales? So the first thing I did was I went to the IUCN and I looked up how are whales doing in the world. And contrary to public opinion, interestingly enough, lots of studies have been done on what people think the status of whales are. The number of people who think many species are already extinct is quite remarkably high. They would be most surprised to know that, in fact, about half the species are least concern. There are some endangered species out there, but it's worth noting that these are species listings, not stock listings. So, for example, blue whales are classified as endangered on this list, yet Trevor, is Trevor here? Trevor's back there blogging or tweeting or whatever he does, updating his page. What are those things? Facebook? Whatever it is. Trevor just published a paper essentially saying that blue whales off the west coast have reached carrying capacity. So you're looking here at these listings. at a stock level, and this is being influenced by the very large populations in the southern hemisphere that are severely depleted and still are severely depleted. However, the question is, how are they doing? So the Whaling Commission has assembled data on every whale stock that we identify and classified them into 3 categories, or at least I classified them into 3 categories, and if I had a very long pole, I'd be able to point at bowheads, which I can't because I'm not 8'2". The plus here indicates that the stock concerned is estimated to be increasing, a minus, it's declining, and a question mark says that we just don't have enough data to really estimate trend. We've actually got abundance estimates for pretty much all of these stocks, just not trend estimates. A very quick glance at this slide will tell you that there is a vast predominance of plus signs. Now, for those of you who manage fisheries, this may come as a surprise that if you don't kill them, they actually increase in abundance, right? In fact, if you do not do that, I believe Tim is teaching ecological modeling, which will help you to understand that if you don't kill them, they actually do increase. There are lots of question marks as well, particularly for the pelagic species, so the sei whales, the Blutis whales. You'll notice most of those stocks are question marks. But generally speaking, given the data we've got, it does appear that the populations are on the increase. The two figures at the bottom of the slide are the 2 stocks that I work on off the west coast in Alaska, bowheads and grey whales. The data for these would make the average fisheries stock assessment scientist drool, and I'll come back to that in a moment. So let's look at US fisheries. The US fisheries are generally evaluated according to 2 criteria. One is what we call it the overfish status, which essentially is the biomass below half of the biomass corresponding to maximum sustainable yield. For those of you who have heard that maximum sustainable yield does not impact fisheries management, talk to me afterwards. And secondly, overfishing is when the fishing mortality rate is higher than that corresponding to maximum sustainable yield. In simple terms, the first one is we don't have enough fish. The second one is we're taking too many out of the water. So how are we doing? Contrary to what you hear, US fisheries are amongst the best managed in the world. And I don't think there's many statistics that would give you a different answer unless you really worked pretty hard at it. So this plot shows fishing mortality relative to FMSY, biomass relative to BMSY. You want ideally to be somewhere around here, right? You want to be fishing at MSY and you want to be a biomass close to BMSY. If you're in this quadrant, you are essentially fishing less than the maximum sustainable yield and your stock is bigger. So if you're from a conservation point of view, this is a good place to be. You do not want to be in this quadrant, right? You've not enough fish and you're fishing too hard as well. The egg plot, I love that term, sort of a density plot, it indicates that, on average US fisheries are somewhere between 1 and 1.5 times the biomass corresponding to BMSY. There are certainly some stocks, the green ones here, particularly the ones down here, that do need work. So let's delve down a little bit. So I'm going back to 2008. This is some NOAA data from the what's called the report to Congress. Don't read everything on this slide. This gives you an idea of how many stocks were overfished below half of BMSY in 2008. Okay, where are we today? Sorry, let me just go back. At the top, we had 45 stocks. We've now got 38 stocks that are overfished. Okay, so 7 fewer. Now, rebuilding stocks is actually quite hard because no matter how hard you try, even if Congress passes a law, Pacific Ocean perch will not be productive, right? There's so much you can do even if you don't fish them. What we can do as fishery managers is affect fishing mortality rate. So in 2008, 41 stocks were subject to overfishing. We're fishing too hard. How are we doing today? We're down to 27. Compared to the world average, this is remarkably good. Given FSSI, this report to Congress has something like 340 stocks or something like that. What? 400. And the prize for numbers goes to... and if you, again, I'm not going to spend too much on this, but I will like to emphasize that a lot of the species that are overfished, these groups over here, are marlins, tunas, basically fisheries for which a lot of the harvest is taken by non-US fisheries. Where are the problems today? They're in New England. They were in New England before, they're in New England today, and I predict that they'll be in New England in the future. Focusing further down, how are we doing off the west coast of the United States? What I'm showing here in the upper panel is the west coast, the lower panel is Alaska. Here we're showing fishing mortality compared to FMSY. So bad is above 1, good is below 1. And what we see is that in recent years, most of these lines are well below 1. Same is true of the North Pacific. Trajectories of biomass off the west coast, pretty much everything is increasing. This one's increasing pretty slowly, but it's very long-lived. Off Alaska, things are looking really good, except for this guy here, okay, which is Pribilof Island blue king crab. What do we know about Pribilof Island blue king crab? Well, looks like we haven't actually fished it in about 20 years. The only factor biologically we know about this stock compared to all other stocks is that Dave Armstrong studied it. Okay, so perhaps that's what we need. Didn't you studied there were plenty of them, right? Scientific crabbing, that's what it's all about. Okay, so, but basically apart from Pribilof Island blue king crab, the Pacific and the North Pacific are amongst the areas of the world where fish stocks are in from a conservation point of view, the highest state. So let's delve down a little bit and talk about providing management advice. Oh, I do have another equation. I'm not allowed to talk about that one. We need 3 things to do a good appraisal of stock status, whether you're a whale, whether you're a crab, whether you're a fish. We need catches, we need measures of abundance, and we need to know something about the age and size of the animals. So let's talk about abundance estimation. Okay, I can count fish. Counting fish is like counting trees, except trees don't move and you can't see them. So I'm going to give you 2 stories of fish stocks for which we have enormous data and almost no knowledge. What I'm showing you here are trajectories of biomass estimated by totally reputable NOAA scientists over a period from 1990 to 2009. Okay? Each of these lines is an estimate of how many animals we've got, or the biomass of them. Essentially, they're using all the same data. Okay? I would argue that as a fishery manager, I'd be a little nervous to know that the estimate of the 1980 biomass has changed from 0.7 million tons to 4 million tons, right? All of these have been provided to managers. So if you're an undergrad student taking a class, as long as you're within 3.2 million tons, you're pretty good. This is Pacific hake. Let's see if we can go down. There are other ways to do this. Come on, there we go. This is now Pacific sardine. Again, it's a very large fishery off the west coast. There are 6 lines here. Each of those 6 lines are outputs of a stock assessment that had exactly the same data. Okay? Small tweaks in the assessment lead to essentially huge changes in how many fish we estimate. What is causing this? And why? What can we do about it? What is causing it is most of the work, most of the surveys that are done of fisheries estimate what we call relative abundance indices. We estimate the trend in the animals. In the whale business, we've spent a lot of time developing techniques to estimate absolute abundance. How many animals do we have by counting them? So remember, fish are like trees but whales, we actually do count them. Moreover, the Whaling Commission has adopted a carrot and stick approach. I like that image. What is the carrot and stick? The carrot and stick is that if you do not have estimates of absolute abundance, your catch limit is 0. Okay? If you have no data, you get no catch. That's the carrot, that's the stick. In fisheries, and I've been around this business for the better part of 30 years now, we use whatever we can find, right? I will not spend a lot of time talking about the sewerage index that was once used in the stock assessment for cow cod in Central California, but it literally was a stinky index. We use whatever we can. There's some development that might be helping us, attempting to synthesize what we know, where we know it, about what's called catchability. In other words, how do our indices of abundance, like catch per unit effort, relate to total abundance? And this is starting to help us address this issue, but the fundamental difference between fisheries and, well, a fundamental difference is the fact that we have absolute abundance estimates for whale stocks, and very few for fisheries. So let's talk about catch control rules. Acme quotas. What are catch control rules? Catch control rules are the functional forms, the mathematical equations we use as scientists to provide management recommendations. So basically we synthesize a lot of data, we put it into Acme quotas, and out comes a recommendation for a scientific catch, or the catch that's recommended scientifically. Ideally, that catch control rule should take uncertainty into account. And as I'll argue in a moment, that's been what was really differentiated whale management from fisheries management, is that in the whale business, we've really focused on reducing catches when there is uncertainty, whereas around the world, that has been something that's really only caught on in recent years. So I'm not going to go through this particular slide. That is the catch control rule that is used, I believe, in the mid-Atlantic. If you can read really quickly, all you would conclude is it's very complicated. On the other hand, this is the one we use off the west coast. Even I can understand that. We've got catch on the y-axis, number of animals on the x-axis, and essentially we just read off the graph. Okay? The question you have to ask is, where did this slope come from? And what happens if we don't know what's going on the x-axis? Right? That's the uncertainty we have to deal with. Now, the Whaling Commission was one of the first organizations to recognize two things. The first one was, we need catch control rules. Why do we need catch control rules? Even in the 1970s and 1980s, the Whaling Commission had got to the point where there were two groups, the whalers and the non-whalers. And the chance of anyone reaching agreement was zero, right? So you had to have an objective way of setting catch limits. And a catch control rule was proposed by Australia back in 1974, referred to as the new management procedure. For those of you who are inventing names of things, don't call them new, because eventually they're the old and then people get really confused. So when we replace the new one, we now got the revised one. So what happens when anyway, let's not go there. How does this catch control rule work? Okay, so on the x-axis is population size in numbers rather than biomass, and on the y-axis is essentially catch. Catches are zero below, remember 54% of carrying capacity? Okay, I can see Ian nodding. Ian remembers his version of this equation. The line is what, over here somewhere? Little low. So catches are zero in what's called a protection stock, increase up to 90% of maximum sustainable yield. Today's fisheries control rules, like the one I showed you in a second ago, are linear lines, right? They just keep increasing. The Whaling Commission put a maximum on this catch of 90% MSY. Why did it do that? To prevent overcapitalization, right? So if you just had a straight line that kept going up, a la what we all get taught in class, if you're at a stock size here, people are going to buy boats to catch those animals. And later on, as the population goes down, there is no sustainable catch. This looks all really good, and we've all talked about it. It didn't work. It failed. It failed for two reasons. One, we don't have this information for most stocks. And at the time, scientifically, we had to produce recommendations for all stocks. And it doesn't handle uncertainty. How do we address this? We move to what's called management strategy evaluation. management strategy evaluation is essentially simulation testing of management strategies or control rules. So we develop a computer program which manages my favorite species, Baleopterus electronicus, the electronic baleen whale. Okay? For those of you who are members of Greenpeace or Sea Shepherd, you do not have to worry about this species. It is in fantastic shape, and if you need another million, all I go to the computer is I just add another million in, and they're great. They don't taste too good though. So we've managed Baleopterus electronicus for many, many years, and drew some fairly important and useful conclusions which are finally making their way into the fisheries arena. We use this approach not just to compare strategies, so essentially if I make the analogy between computer testing of control rules and this thing, this is your flight simulator. For those of you who have ever flown a plane, anyone flown a plane? One or two people have flown a plane. Who wants to fly the plane where the guy failed on the flight simulator, right? Probably not. So we're using the same approach to actually select how we manage whale and now fish stocks. More than that, we're now starting to use these approaches to look at things that we don't know much about, and in particular, climate change and environmental degradation. What did the IWC learn from this whole process? It learned things that we as fisheries scientists need to think about. The first one is methods based on CPUE don't work. Okay? That's not good, given I would say half of our fisheries are managed based on CPUE, even in the United States. Looking at biological parameters, pregnancy rates, natural mortality rates, useless. And most importantly of all is that we need to recognize this uncertainty and essentially reduce catch limits when you have fewer data and uncertain data. And that has been formalized in how we manage whale stocks. So I'm going to talk a little bit about space and stock structure, because there's geneticists here and you like about stock structure. According to Wikipedia, that's the definition of a stock. It's a fish stocks, a subpopulation, a particular species of fish for which the intrinsic predator, blah, 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 blah. That's rubbish. This is how we do it in the real world. Fish stocks are subpopulations as defined by people who define fish stocks. Okay? Who's defined stocks? Anyone disagree with me on that? Got to find a geneticist. Oh, somehow these slides are out of order. That's fish in space. I think that's cool. Okay. So, does space matter? We all know space is the final frontier and all that sort of stuff. Now, I'm very quickly going to state a fact and then invite you to come to my quantitative seminar tomorrow. But that's the number that Julia didn't mention. Number of seminars given on consecutive days of the week. I'm talking today and tomorrow. That may also give an index of my IQ being less than 5, but that's a different issue. The main point here is that if we get our stock structure wrong, in other words, if we ignore what Lawrence is saying, we can get our estimates of abundance dramatically wrong. I won't go into details, but essentially on the y-axis is error. These are percentages, so any number of 100 means that you are out by 100%. That is not a passing grade, even in fish stock assessment. Not only is that the case, using information from incorrect assessments or a poor understanding of stock structure can lead not just to the science being wrong, but failure to achieve management goals. This is a plot from a paper by Ingrid Spice, which is almost accepted. It should actually say almost accepted here. Population size on the y-axis. On the x-axis is essentially number of populations that you are managing, but you do not know that. Okay? Most of the time, we know very little about population structure. And what Ingrid did was looked at different harvest strategies. As I say, this is 0.4 here is the target level. 0.2 is the threshold below which you do not want to go. Right? So the perfect world, all the lines are at 0.4. These are different strategies. You'll see that depending on how you use or take account of space in assessments, you can go radically wrong. Now, in the whale business, we're no better at identifying stocks in populations than anybody else is, right? Genetics is just as difficult when you're dealing with a whale population as it is with a salmon. And so what we've tended to do in the whale business, which I believe is something we need to think about in fisheries, is essentially to look at multiple assumptions about stocks and take them into account when we're making our management decisions. This is humpbacks in the North Pacific. It's a very complicated case. There's at least 2 breeding grounds, and those animals move to up to 5 different feeding grounds. So when you're setting quotas, and they are harvested over here, and in fact over here, you need to take into account that the animals could be in many different places when you're conducting surveys. So one solution to understanding and managing for stock structure uncertainty is to do more science. The other way is to essentially think smart, okay? We aren't going to solve every stock structure problem, and so what a number of fisheries management organizations, including the North Pacific Fishery Management Council, are doing is essentially, if we have 3 areas, how do we manage this? Well, we could calculate catch limits for each area. We can calculate catch limits for the whole area. And essentially what we're moving to is an approach where we calculate the catch limit for the whole area and we spread it spatially, okay? Essentially, from a risk management point of view, what you want to do to avoid getting it wrong is spread your risk, just like you do in the stock exchange. And you can do the same thing when you're managing populations. And this is one of the fundamental components of the whale management scheme that would be in place if the moratorium was lifted. Finally, science, management, and politics. So I've been working on Pacific sardine for now a couple of years, and I think we need Julia to help us with the arithmetic here. Let's see how we manage this population, right? So we've got 3 countries that harvest the species: Mexico, the US, and Canada. So how does the quota work? Well, the Canadians take 5% of the biomass that's out there, less 150,000 tons. So call it 5%. We'll go 5%. The US has a control rule, which is similar to that, and it takes 87% of the quota. So 87 plus 5 is, come on, this is not hard. Where's Vince? 92, right? So by arithmetic, how much does Mexico get? 39%. Okay? So we have not just a science issue, but a political negotiation management issue. So I'm going to grade the world. That's what happens if you don't teach as much as you used to. You just get desperate to grade things. How are we doing in rebuilding fisheries? I would argue that US fisheries, I'm not putting the whole world in here, are probably A to B. They're doing at least as well as most of the rest of the world. I'd argue that for baleen whales, we're as close to as A as anybody. However, there are areas. Bycatch management. I haven't talked much about bycatch, but bycatch is a problem in fisheries and in whales. In the US, there's probably the most sophisticated marine mammal bycatch management system thanks to the Marine Mammal Protection Act, but there are many problems about bycatch management which remain. Spatial structure. I think we're a long way away from solving spatial structure, which is why, Lawrence, you need to keep working. Is Kerry here somewhere? Come on, Kerry, got to keep working. I think in the whale business we've started to address this through risk management strategies, but we've got a long way to go. Simulation tested control rules. Have we tested our management system? The Whaling Commission only uses tested control rules. In fisheries, even in the United States, we use whatever we can. Final thing I want to emphasize here is that I've talked about baleen whales, okay? Baleen whales are easy to manage. I'm not going to talk about toothed whales because they are hard to manage. So the status of baleen whales is substantially better than that of toothed whales. And part of the reason might be that the International Whaling Commission has how much jurisdiction over toothed whales? Sperm whales and nothing else. Okay? So no control, it's all national jurisdiction. So to summarize, because I know you're all getting thirsty and beer is out there, and at the end of the day the speaker is the gap between Julia introducing the speaker and beer, right? Where do I see the world moving in the not too distant future, or at least I hope to see? Firstly, and this university and this school is at the forefront of this, is to start to continue to expect that our control rules we use for fisheries have the same quality as those we use for baleen whales. We need to move, we need to invest substantially in getting rid of that problem I showed you with Pacific whiting and Pacific sardine, where by using data which only tell us about trend, we are unable to estimate absolute abundance. We need a deeper consideration of what it means, what a stock means, and how do we define them. I don't think defining a stock by those who define stocks is really the correct way to go. In terms of whaling, we're doing generally a pretty good job. There is, however, this group, the toothed whales, where we really haven't explored, we haven't really thought about in the ways we have for baleen whales, particularly outside the United States. I'm not going to talk about this dot point to do with clarification of whaling. Mangal will give you everything you wanted to know and more about scientific whaling, what it means, how it developed, and where it stands today. So the final set of things I want to emphasize where I think the next generation needs to go is the Whaling Commission has established standards. If you don't have data, you don't get catch. Do we need the same thing for fisheries? And what are the implications if you can't satisfy those standards? We need more clarity on management objectives. Every talk I've ever given has indicated that our management objectives, be they fisheries, be they whales, probably be they trees, really are not providing the clarity that we as scientists need. And finally, and this is outside my pay grade, more and more we're seeing that the biggest problems we have with fisheries or whale management is jurisdictional. The sardine case. Your quota really has to add to 100%. So I'd like to stop there, acknowledge Greg Donovan, who has the coolest title of anyone. Professor Emeritus, it's good. Director, cool. Dean, wonderful. Head of Science, the best. And as you ask questions, I want you to read an announcement from the US Bureau of Fisheries, which emphasized that whale meat this is meat, not fish. Excellent and economical for soups, stews, curries, and roasts. Thank you very much. 5 minutes.
I'm sure that André would be willing to entertain a few provocative questions. Should you wish to ask?
David.
Your notion about applying to fisheries, the whaling requirement or characteristic is you don't have data, you don't get caps. Because so much of the data for fisheries is supposed to come from federal NOAA labs, who ultimately is responsible if there is insufficient data leading to you don't get caps?
Right, I've heard that argument many times. Well, what happens? Pressure, right? That's how our political system works. It works through pressure. If there is a need and there is a stick, it's amazing what can be found. And that's certainly true of some of those whale operations. Essentially the bowhead data, beautiful 20 years of data, a lot of that arose because I'm going to get the year wrong, 1970s. Doug, are you here? Doug DeMaster, is he here anyway? Okay, he was there, so I can say whatever I like. Good. Essentially, in 1977, the harvest was essentially going to be shut off, right? Because we had no data, and we thought there was only 2,000 animals. Money was found, a survey was done, the estimate was 7,000, they got a quota, we've had good data ever since. So it's a question of moving from we can't afford this, we can never do it, to if you don't do it, bad things happen. Moving from A to B is not an easy thing to do, but it's the only way you're going to get there. Saying this is a really great idea, you need to collect more data, ain't going to get you there.
So for how many big Antarctic stocks are there studies how good are they?
For the Antarctic stocks, okay, so Trevor is probably the world expert on this particular problem. We've got Antarctic estimates that I'd say are reasonable for minke whales. We've got blue whales are fairly good. Humpbacks are excellent. Fins are sort of dubious. Says are non-existent. So again, same. The IWC coordinated what's called the International Decade for Cetacean Research, IDCR, which lasted more than a decade. Just gives you the whole math thing running into trouble. And basically, they did 3 circumpolar cruises over 6 years. It takes a long time to survey the whole Antarctic using your standard zigzag, technology. How many boats did they have, Trevor? 2 at a time? 2 to 3 boats at a time. Took them 6 years at a time. They've done it 3 times. The Japanese, and you'll hear more about this maybe next week, they focus on essentially 1/3 of the Antarctic and essentially go back to half of that every single year under the scientific whaling program. So in that particular area, we've got 20 years of absolute abundance data on all the species that are south enough to be surveyed. Brunel.
André, what are the checks and balances built into ensuring credibility of the data? Because I would imagine that the US is possibly responsible, but there are a number of dodgy countries out there.
You mean like South Africa, which she is a representative of a country that was a pirate whaling nation in the 1950s. There are a few other countries.
Case in point.
Okay, so there's 2 types of data we're talking about here. One is catch data, and one is abundance data from surveys. Dealing with the survey data first, any survey that is used by the Whaling Commission has to have an international observer on board. So when you do your cruise, you have a representative of the scientific committee appointed to be on that cruise as an overseer. Now, we don't think any have been thrown over the side, but so basically there is a formal exchange program for all the surveys. You'll hear on next week that is not true of the Japanese scientific whaling program. They do not have this oversight because they're working in a different universe. Catch data are a problem. We know that the Soviets, they're not the Russians, completely different group of people. The Russians accuse the Soviets. I don't go there. The Soviets clearly were underreporting substantially. They were catching, Trevor, you probably know this, certainly blues. They were taking humpbacks after the fishery was formally closed. In true, almost sort of misreporting style, they then converted them into minke whales. So not only did they screw up our assessments of blue whales, they didn't really help our minke whale assessments because we got these animals that, interestingly enough, they never had length data. And we never did understand why these minke whales didn't have length data until we realized they were actually never caught. So they didn't obviously have length. In the following in 1976, ever since then there have been observers on whaling boats. So any boat that is registered by the Whaling Commission, and remember, a country that's not a member of the Whaling Commission, like, where's Brooke, name the most famous country that left the Whaling Commission in protest. Canada! So there are these rogue countries like Canada, but if you're a member of the Whaling Commission, there will be a observer, just like in a sort of fishing boat type thing. So there's still a lot of controversy about that, and it only applies to commercial whaling. So for example, there is no Japanese who goes up to Alaska to check that the US harvest is within the quota. It's all the commercial side.
So, André, I'd like to ask a question.
Uh-oh.
It seems that you spent a lot of time convincing us that perhaps we should hold the standards of whaling data up to fisheries and see whether, in fact, we might change how we manage fisheries. Can't you also ask the question, shouldn't we start whaling?
Oh, you had to ask that question. So, and I asked the class this morning, scientific whaling. I was trying to avoid scientific. No, let's start with scientific whaling. So, I'll get to commercial whaling. What do you think the fishing mortality rate by the Japanese in the Antarctic is? Catch divided by, okay, where's my salmon? I had a salmon biologist Salmon, what's the harvest rate for salmon? A good sustainable harvest rate. Come on. Is it 2%? 20%? It's probably about 40%. What do you think the harvest rate in the Antarctic is right now? Okay, well, let's go to POP. What's the harvest rate? What's the sustainable harvest rate of POP? 3 or 4%? 3 or 4%. If commercial whaling was started tomorrow, right, and POP and baleen whales are pretty much identical in productivity, the harvest rate would be 0.5%. You could easily harvest, under our regulations, you could easily sustainably harvest minke whales and those pests of the sea, the humpbacks, which are actually more productive than virtually anything, any fish stock we deal with. So humpbacks would easily be harvested under the management system we developed. You could do it if you wanted to, and probably safer than fisheries.
So, in your opinion,
Uh-oh. I'm watching these little mines. There's a big hole there. Yes.
well, you are a reputable scientist involved in the Whaling Commission.
If such a thing exists, yes.
What would you say? I mean, why don't whale scientists and fishery scientists come out and simply say, yes, we should, yes, commercial harvest is possible, is acceptable, is sustainable?
The scientific committee of the Whaling Commission have made that statement. That was, okay, so now we get into the politics of the game here, because this is all a game. In 1982, the moratorium was put in place, and whaling pretty much stopped in 1985-86. As part of that comprehensive assessment, remember the texts are underlined? We had to do a comprehensive assessment. Part of that comprehensive assessment was to come up with a new management procedure that was robust and all those good things. In 1992, we did. We came up with what's called the revised management procedure. And the entire scientific committee from Australia to Japan voted on that. That's the only thing we voted on in 30 years. And everyone voted this is appropriate, right? What happened when we gave it to the commission? They rejected it. Why? They didn't want to know, right? So scientifically we can do it. Politically, that's, if there's an issue, it's politics. It's nothing to do with science. And on that note,